Find the first four terms in this sequence. All right, well, that looks awful, but that's all right, no big deal. We are being asked to find a sub 1, a sub 2, a sub 3, a sub 4. And it's a matter of you replacing every n with the number that we're talking about. So it's just PEMDAS a bunch of times. So 2 times 1 plus 1 over 1 to the third power. Okay, we could do two things at the same time. 2 times 1 is 2. 2 plus 1 over 1 to the third power is 1, right? That becomes 3 over 1. 3 over 1 is 3. Okay, NBD as the kids say. Let's do it again. 2 times 2 plus 1 over 2 to the third power. That's going to be 4 plus 1 over 8, which is going to be 5/8. Gross. Let's do it again. 2 times 3 plus 1 over 3 to the third power. That's going to be 6 plus 1 over 27, which is going to be 7 over 27, which is, there's nothing we can do there. Gross again. One more time. 2 times 4 plus 1 over 4 to the third power. That's going to be 8 plus 1 over 64, which is going to be 9 over 64. So my first four terms are 3, 5/8, 7/27, and 9/64. Fun stuff. Find the 10th term in each sequence. All right, so I'm going to do this very old school, nothing crazy. This is a recursive arithmetic sequence. I hate these. And for me, this is the best way to do it. Okay, so if this is your first term, what this is telling you is to get to the next term, you just add 10. Okay, so so like if I wanted a sub 2, I would do a sub 2 minus 1, which is a sub 1 plus 10. So if I want my 10th term, okay, so let me get rid of this mess right here. Okay, this is my first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. I need to make my way there by adding 10 each time. So the first is 11, second is 21, third is 31, 41, 51, sixth is 61, 71, eighth is 81, 91, and just like the amount of Dalmatians there are in that one movie, the 10th term is 101. So that's how you do it. Write the formula of the arithmetic sequence. An arithmetic sequence is given to you by this formula right here. A sub n equals a sub 1 plus n minus 1 times d. A sub n is the term that you're looking for, like the 5th term, the 8th term, whatever. A sub 1 is the first term, in this case, 9. N is whatever term you're looking for, so we're going to leave n if we're going to come up with the formula. And d is the common difference. The common difference is what you add from one number to the next to get to the next number. Okay, so 9 plus 5 is 14, and 14 plus 5 is 19, so the common difference is going to be 5. So to make a nice little formula for this, you would say a sub n is going to equal your first term, which is 9, plus n minus 1 times the common difference, which is 5. Some teachers might want you to rewrite it like this. Throw that 5 out in front. Either way, it's all good. It's fine. Fine and dandy like sour candy. But there you have it. Write the formula for the arithmetic sequence. The formula for the arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. A sub n is going to be the term that you're looking for. That's what we're going to find here. A sub 1 is your first term, which is negative 3. N is that same n that we see over here, so we're going to leave n. Minus 1 is just minus 1. And d is the common difference. Now, the common difference is what you add to get from this number to the next number, this number to the next number. And it looks like what we're doing to get from -3 to -23 is we subtract 20, or we add -20. We add -20. So that's going to be our common difference. So a sub n is going to equal our first term, which is -3, plus n minus 1 times the common difference, which is -20. Looks kind of sloppy, so maybe some teachers might want you to write that -20 out in front, so we'll do that. -3 minus 20 times the quantity n minus 1. Either of those formulas are good. This one just looks a little bit better. Find the 17th term in the arithmetic sequence. Well, what I want to do is I want to find the actual formula for the arithmetic sequence so I don't have to count over a bunch of times. So the arithmetic sequence formula is a sub n equals a sub 1 plus n minus 1 times d. A sub n is going to be the term that we're talking about. A sub 1 is the first term, which is -7. N is going to be the same n, and d is going to be the common difference. Now, the common difference is the number that you add from one term to get to the next. So it looks like we're adding a -2 to get from one number to the next. So my common difference is -2. So my formula is going to be a sub n equals -7 plus n minus 1 times the quantity -2. I care about the 17th term. So I'm going to do a sub 17 equals -7 plus 17 minus 1 times -2. Now it's just a PEMDAS problem. -7 is still there. 17 minus 1 is 16, so 16 times -2. Continuing PEMDAS, 16 times -2 is going to be -32, and -7 minus 32 is -39. And that's how you do it. Find the formula of an arithmetic sequence whose 18th term is that gross number and 38th term is that gross number. All right, no big deal. I just need to find the common difference. The way you can find the common difference is treat this like the slope formula. Okay, so what I'll do is the number that I have, 7362, matches up with 38. I'm going to subtract 3362, convenient numbers, and 18. This is going to get me my common difference. So I have 4,000? 4,000 on the dot. Over 20 on the dot. And that's going to give me 200 on the dot. My common difference is 200. Okay. Now, I'm not home free yet. What I have is I have a common difference. I can start by building my formula. Remember, my arithmetic sequence formula is a sub n equals a sub 1 plus n minus 1 times d. Right now, all I have is a sub n equals a sub 1 plus n minus 1 times 200. Now, I don't have a sub 1. Once I get a sub 1, I can figure out what my formula is in general. So what I can do is I can use one of these guys right here and say, all right, well, we'll let n be u. And so that would be my a sub n, and that will give me eventually a sub 1. So a sub n, 3362, is going to equal a sub 1, which is what I'm trying to find, plus n, which I called 18, minus 1 times 200. So a little bit of Algebra 2, a sub 1 plus 17 times 200 is going to be 3,602. A sub 1 plus 3,400, right? Minus 3,400 from both sides, minus 3,400 from both sides. And that looks like that's going to get us -38 equals a sub 1. So using all that information, using this information right here and this information right here, we can come up with the formula a sub n equals -38 plus n minus 1 times 200. And if you have a picky teacher that says that 200 should be out in front, then fine. A sub n equals negative 38 plus 200 times n minus 1. They're both the same. They're both fine. I guess you look prettier, so we'll circle box whatever you. But that's how you do it. Write the formula for the geometric sequence. The formula for a geometric sequence is g sub n equals g sub 1 times r to the n minus 1. G sub n is the term that you're talking about. G sub 1 is the first term. R is going to be what you multiply to get from one number to the next. So it looks to me that if I multiply negative 1 by negative 6, I get 6. And if I multiply 6 by negative 6, I get negative 36, and back and forth. So negative 6 is my R. Okay, so from this information, we have enough that we can write out our formula. G sub n is going to equal negative 1 times, and I'm going to put this in parentheses, negative 6 to the n minus 1. So I guess technically that negative 1, sloppy, G sub n equals negative parentheses negative 6 to the n minus 1. Maybe that looks a little bit better. But either way, I guess is sufficient. That's what you get. Write the formula for a geometric sequence. All right, the formula, generally speaking, for a geometric sequence is g sub n equals g sub 1 times r to the n minus 1. G sub n is the term that you're talking about. G sub 1 is the first term, which is negative 2. R is going to be the number that you multiply to get from one term to the next. So negative 2 times regular 2 is negative 4. Times regular 2 is negative 8. Times regular 2 is negative 16. R is 2. Okay, so now I have enough information to just write this out. G sub n is going to equal my first term, which is negative 2, and I like to put it in parentheses, it just looks nicer, times r, which is regular 2, to the n minus 1. That's your geometric sequence. What is the eighth term of a geometric sequence whose first term is 80 and second term is 40? All right, so let's write out the general formula for a geometric sequence. G sub n equals g sub 1 times r to the n minus 1. G sub 1 is my first term. We're in luck. We know what that is. That's 80. My second term is 40. And if we know that this is geometric, the only way we can get from 80 to 40 is if we multiply by a half. So that tells us that our common ratio is 1/2. So we now have a formula. G sub n equals 80 times the quantity 1/2 to the n minus 1. Now I want the eighth term, so I'm going to replace every n here with 8, and that'll get me my answer. G sub 8 is going to equal 80 times 1 over 2 to the 8 minus 1 power. So that's 80 times 1/2 to the 7th power. That is going to be 80 times 1 over 128. 128. So let me think here. I could probably, let me see, 80 over 128. Those are both divisible by 16. So if I divide the top and the bottom by 16, I get 5 over 32. No. 8. Sigma, sigma boy, sigma boy, sigma boy. Sigma notation, also known as summation notation. Basically what you do is you're given a beginning, you're given an end, and you're supposed to add everything from start to finish. So, basically, plug in 1. add, plug in 2, add, plug in 3, add, plug in 4, add, plug in 5, add. So let's set that up. So you got the m equals 1 version, you got the m equals 2 version, you got the m equals 3 version, you got the m equals 4 version, you got the m equals 5 version. You're going to plug in 1, so 4 parentheses 1 squared plus 4, close it, plus 4 parentheses 2 squared plus 4, close it, plus 4 parentheses 3 squared plus 4, close it, plus 4 parentheses 4 squared plus 4, close it. Lots of 4s. It's like we're playing golf. It's a joke. 4 times parentheses 5 squared plus 4, close it. All right, no mistakes made. Now it's just PEMDAS. 1 squared is 1, so 4 times 1 plus 4, plus 2 squared is 4, 4 times 4 plus 4, plus 3 squared is 9, 4 times 9 plus 4, plus 4 squared is 16, 4 times 16 plus 4, plus 5 squared is 25, 4 times 25 plus 1, 4, oof, 4, close one. I don't know why I said 1. All right, 4 times 1, so we got 4 plus 4, 4 times 4, 16 plus 4, 4 times 9, 36 plus 4, 4 times 16, 64 plus 4, 4 times 25, 100 plus 4. Almost there. Almost there. 8 plus 20 plus 40 plus 68 plus 104. Let me see. These guys add up to make 60, right? So 60 plus 68 is 68. 68 plus 68 is 136, and 136 plus 104 is 240. So there you have it, sigma notation, also known as summation notation. You have a beginning, you have an end, you add the stuff. Tons of fun. Sigma, sigma boy, sigma boy, sigma boy. That's a sigma. And what's the sigma? That's the sigma. Look at me, all these trendy 2025 memes that I'm doing right now. Basically, what you're doing with sigma notation is you're given a function. You have a beginning, you have an end. You plug in that number, and you keep adding the next integer until you hit the end. So we're going to plug in 4. We're going to plug in 5. We're going to plug in 6. We're going to plug in 7. We're going to plug in 8. And we're going to plug in 9. And then we're going to add up all of those guys. So let's do just that. You have 20 minus 4 squared plus 20 minus 5 squared plus 20 minus 6 squared plus 20 minus 7 squared plus 20 minus 8 squared plus 20 minus 9 squared. All right, 20 minus 16 plus 20 minus 25 plus 20 minus 36 plus 20 minus 49 plus 20 minus 64 plus 20 minus 81. Let's get a different color in here. Let's get some blue. 4 plus negative 5 plus negative 16 plus negative 29 plus negative 44 plus negative 61. And just to save some time, when you add all of these up, you will get negative 151. I snuck away and did that on my calculator. But that's how you do a sigma notation problem. You start with the beginning, you have an end, and you just add up every time you plug in an integer from beginning to end. Fun stuff. Write as sigma notation. Well, what I have in front of me is I have the perfect squares. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So if I start at 1 squared, here's my sigma, I'll say something like n equals 1. Okay, and I'll start at n squared, or 1, and then I'll use n squared, and then I'm going to end when it's 5. So that is something that this can be written as. So that's a sigma notation example of 1 plus 4 plus 9 plus 16 plus 25. Write as sigma notation. All right, so sigma notation is you, okay, the sigma. You're going to start somewhere, and tell you what, since there's a 1 here, why don't I start with a 1? And it seems like I'm going to end with a 6, so why don't I do a 6? So there's a pattern going on here, and that pattern is that of a fraction. It looks like the numerator is just me starting at 1 and then working my way up every integer. So it's going to be n here. On the bottom, it's going to be 1 more than that n, so I will use n plus 1 as my denominator. And that should do it. That's the sigma notation of those groups of fractions right there. Not so bad. Use the formula to calculate the arithmetic series. Well, the arithmetic series formula is S sub n equals n times the first term a sub 1 plus the nth term a sub n, all divided by 2. And I have enough information where I can plug stuff in. For example, I have my first term a sub 1. I have my nth term, which is going to be a sub n. And 1, 2, 3, 4, 5, 6, n is going to be 6. Okay, so s sub 6 is going to be 6 times my first term, which is 13, plus my sixth term, which is 23, all divided by 2. So now it's just a matter of doing some PEMDAS. 6 times 13 plus 23 is going to be 36. So 36 divided by 2. 36 divided by 2 is 18. And 6 times 18 is 108. So that's how you can add these guys up without really having to do too much. Fun stuff. Use the formula to calculate the arithmetic series. Well, the formula for an arithmetic series is S sub n equals n times the first term plus the nth term, all divided by 2. So my first term would be this guy, 39, which is a sub 1. Okay, we are going 1, 2, 3, 4 terms, so n is going to be 4. And so a sub n, or a sub 4, is going to be that 69 right there. Nice. Now what I do is I say s sub n, or s sub 4 now, for these 4 terms, is going to equal my n, which is 4, times the quantity 39 plus 69, nice, all divided by 2. Okay, now it's just a PEMDAS problem. Okay, 4 times 39 plus 69, nice, is going to be 108. So 108 divided by 2. 108 divided by 2 is 56. Nope, 54. 54. And 4 times 54 is 216. Sigma, sigma boy, sigma boy, sigma boy. Wow, look at this sigma guy. We start at 1 and end at 35. Now, normally with a nice sigma notation, we would just add a bunch of stuff up, but not here. I'm going to use 2 shortcuts. Shortcut number 1 is if I have just a constant, right, and I start at 1 and I end at some number, the shortcut is I could just do c times that number that I end. That's my shortcut. That's going to help me take care of this -2 part. Now, the part that's going to help me take care of k is if I start at 1 and end at some random number, I'm going to do n times n plus 1 all over 2. So those are my 2 shortcuts, right? How am I going to set this up to make it look like that? Well, watch. I'm going to first do the 5k and rip the 5 out in front of the sigma. Okay, so I'm allowed to do that. I'm allowed to do that. That lets me focus on just the k. Then I'm going to subtract the sigma notation, k equals 1, ending at 35, of 2. Now, these guys look more like these guys. And it's not that bad. Okay? It's not that bad. Should have put a k there. It's not that bad. So, all right. 5 times. Now let's use that where my k is just a k. I'm going to have n, which is 35. So 35 times 35 plus 1 all over 2. Minus, and then I'm going to use Cn. So my C was 2, and my constant is n, or my ending is 35. So I'm going to have that. And now it's just a PEMDAS problem. 5 times 35 times 36, all divided by 2, minus 70. All right, let's move that over here. 35 times 36 is 1,260. So divide that by 2. I'll get there in a minute. Minus 70. So dividing that by 2 is 630. 630. Let's make it a little bit larger because we're dividing it by 2. Minus 70. That is going to be 3,150. Minus 70 is going to be 3,080. And that's how you do it. Sigma notation. Use the formula to calculate the geometric series. Well, the formula for a geometric series is S sub n equals G sub 1. Now, a lot of teachers might use A sub 1, but G is for geometric. And if you're thinking pre-calculus thoughts, you're going to use G's for geometric. It's all the same. 1 minus r to the n over 1 minus r. Now, what is r? What is n? Well, n is the number of terms that we're talking about. 1, 2, 3, 4, 5, so n is 5. Okay, g sub 1 is the first term, like I said, so that's going to be negative 2. And what else? We've got r, which is what you multiply to get from one term to the next. Okay, that's my common ratio. If I multiply everything by 6, we get from one term to the next, so 6 is going to be my r. Now it's a matter of us plugging stuff in. The first 5 terms of this series is going to be negative 2 times 1 minus r, which is 6, to the n, which is 5, over 1 minus regular 6. Okay, so negative 2 times 1 minus 7,776 is going to be 6 to the 5th power, believe it or not. And that's going to be over 1 minus 6 still. Okay, so negative 2 times 1 minus 7776 is going to be negative 7775. And then you're going to be over negative 5. This number inside here becomes 1,555. Bet you didn't know that. And then when you multiply that by 2, you get 3,110. But it's negative. Oh, that was a close one. I was going to say, yeah, I forgot that negative 2 out here. So don't forget the negative either. It's negative because all of these are negative. You're adding those up. I knew something didn't seem right at the end there. But I fixed my mistake. Hopefully you didn't notice too much, and hopefully you weren't getting too angry. I was just so hyper-focused on what these numbers were, I think. I don't know. But yeah, that's what you get. And if you wanted to check your work, you just, add those up and see what happens. But you should get that. Sigma, sigma boy, sigma boy, sigma boy. Thankfully, that's going to be the last time I do that. We are to evaluate sigma notation starting at 1, ending at 7, and it's going to be 4 to the k minus 1. So what we'll do is we'll just plug these in straight up. We'll plug in what happens when k is 1, when k is 2, when k is 3, when k is 4, when k is 5, when k is 6, and when k is 7. And then what we do is we add them all up. So we've got 4 to the k minus 1, which is 4 to the 1 minus 1, plus 4 to the k minus 1, which is 4 to the 2 minus 1, plus 4 to the 3 minus 1, plus 4 to the 4 minus 1, plus 4 to the 5 minus 1, running out of room, plus 4 to the 6 minus 1, just saved it, plus 4 to the 7 minus 1. So your 4 to the 0th, 4 to the 1st, 4 to the 2nd, 4 to the 3rd, 4 to the 4th, 4 to the 5th, 4 to the 6th. Anything to the 0th power, big fat 1. 4 to the 1st is 4. 4 squared is a fun game, but it's also 16. 4 to the 3rd is 64. 4 to the 4th is 256. 4 to the 5th power is 1024. And 4 to the 6th power is 4096. 1 plus 4 plus 16 plus 64 plus 256 plus 1024 plus 4096. 5,461, says Siri across the room. All right. So that's how you do it. Not the prettiest, flower in the bouquet, but we got it. I don't know why. Just like and subscribe, please.